Welcome home, students. Today we are going to be reviewing translations, reflections, and rotations on the coordinate plane. This is it's a very picturesque kind of math lesson. We're going to be looking at a lot of artwork and trying to figure out what kinds of movements we're talking about. So when we talk about translations, reflections, and rotations, these are different kinds of movement on the coordinate plane. We call them rigid motion. Okay? The first thing we have is something called a translation. I take a triangle and I slide it over. That's what we call a translation. Now, in kid words, they call that a slide, but in math words, we call that a translation. Okay, the next form of movement we have, of rigid motion, is something called a rotation. I take that right triangle, and I turn it, and that's called a rotation. So we have a translation, which is a slide, a rotation, which is a turn. And then the last form of rigid motion is called a reflection. So imagine if I had a mirror right there, what would it look like? If I put a mirror exactly right next to the first triangle, laid the mirror there, what would it look like in the reflection? It would look like the triangle was like that. It's reflected exactly on the other half. Okay, so again, in kid words, we say slide, turn, and this they call a flip. But in math words, and you really should get used to using this language, it's translation, rotation, reflection. Okay. So here's an example of how we do translations in math. Okay. The triangle below is translated 5 units to the right and 4 units down. So notice the original D that we have. I'm going to move 5 units to the right. 1, 2, 3, 4, 5. And here's the new D. Oh, not yet, because then I have to go then down 4 units. 1, 2, 3, 4. And here's my new, so 1, 2, 3, 4, 5, 1, 2, 3, 4. And this is my new D. Now, how do I show D? I would write, since this is the copy of the original D, we're going to put this little tick mark, and that means the image of D. D is the original, and we call this other one the image of D. I'm going to do the same thing to E. Now I'm going to move to the right 5. 1, 2, 3, 4, 5. And then down 1, 2, 3, 4. And this is my image of E. Okay. And then I'm also looking at the original problem, the original C. We always start at the original, not at the origin. We start at the original point. And we're going to move 5 units to the right. 1, 2, 3, 4, 5. And then down 1, 2, 3, 4. And that is my new. It's C and it's prime. We call that C prime, E prime, D prime. Okay? So the image, we use that little prime mark. And then we connect those points. And now my question to you is, which of those 3 rigid motions happened? Was it rotated? Was it slid? Or was it a translation, which is a slide? Was it rotated, which is a turn? Or is it reflected? Okay, in the middle of it. And so hopefully you are telling us that it was a translation, which is a slide. Or a slide, which is a translation. Now, many times if we're going to do this in math, we may write the original coordinate. And so if I'm going to go 5 units to the right, that's in a positive direction. That's doing, what am I doing to the original x and the original y? Okay, we're taking that original x and we're adding 5. And what am I doing to the original y? Since we're going down, we're subtracting 4. Now we can just do that right here without even counting the boxes, or you can count the boxes, it doesn't matter. So here I'm going, -5 plus 5, so that new point would be 0, and the new point 1 minus 4 would be -3. So my new point would be at 0, -3. All right? And we're going to keep doing that. The next one, if D is -2, 4, and I add 5, positive 5 to 2, I would get -3 and -4. Where am I getting that from? Since it says 5 units to the right, that means it's to the right, I'm adding it to my x. I'm adding it to my x. So I'm saying x plus 5, because it's 5 to the right. If it were 5 to the left, I would subtract from x. And now because it says up and down, because it says go down, I'm taking my y and going down on the number line is negative. When we go up on the number line, it's positive. Okay? And so I have D prime is plus 5 is -3, and minus 4 is 0. Okay? And now we're going to do our E, which is plus 5. Take that 0, add 5, and it's 5. And take 2, subtract 4. We get -2, and then we collect. Now, triangle C prime, D prime, E prime is what we say is the image of triangle CDE. Here's the original. Here is the copy, and we call it the image of. CDE is called a pre-image. Okay, triangle CDE. All right. So, again, there's the rule. Those are the new points. And so this is what we call a translation. All right. Now, let's see if we can figure out what we're doing from the original M to the new M. I'm going to start. So, from M, this is a translation. And so the original M is at, I'm going to start here, 1 over 1, 2, 3. So it's 1, 3, 1 across. I'm starting at the origin. I count over 1, 1, 3. That's the original. Okay. And now, notice sorry, I didn't mean to do that. What am I doing to the original x? Okay, so if we can say x. If the original is x, y. Now let's count. My x movement is 1, 2, 3, 4, 5, 6. So since I'm going to the left, it's -6. And then my y, I'm then going down, -1, 2, 3, 4. So it's y minus 4. That's the rule. Now you'll see that each point, we don't actually even need that. We can take each point is doing the same thing. So if I start on N, you'll see, and I go over 1, 2, 3, 4, 5, 6, and then go down 1, 2, 3, 4, you'll see that I landed at N prime. So we go from X comma Y, and we figure how many am I moving to the right or left. Remember, this is your across movement, and this is your up or down. If it's positive, you go up. If it's negative, you go down. If it's positive, you go right. If it's negative, you go left. Okay, pause the recording and try the next one on your own. All right, let's check our work. So we'll look at the original J. You always have to start at the first J, not the J prime. Okay, notice to get from the black J to the red J prime, I'm going to have to go to the right. So that's going to be a positive movement. And I'm going to go, let's not follow that. We're going to do our crossword first. So I'm going to go my X comma Y. So I'm starting here and I'm going 1, 2, 3, 4, 5, 6, 7, positive 7. So I'm going to do X plus 7, and then I'm going 1, 2. Y minus 2, since it's down. Now, do I have to check the K? Should be the same thing. We're just looking for the rule. Now, don't worry if you're not getting these. Now, because they're going to go far more in depth as you guys are learning. This was just meant to. So I really kind of wanted to just talk about the movement. So let's put this on pause and now look at a little bit more. Let's look at reflectional symmetry. Okay, reflectional symmetry is when you have a mirror image of the other half of it. So a line of symmetry divides a picture or a figure into two congruent parts. So in the butterfly, where would my line of symmetry be? Would it be across? If I put the mirror here, is the top half looking exactly like the bottom half? No. So it would have to be right here in the center. Right? And if we take our happy face, my line of symmetry would go again right through that center. This is called a line of symmetry. So a lot of language before. Okay, I want you to pause the recording and I want you to see how many possible lines of symmetry you can draw for each figure. Pause it and let's check. All right, let's check our work. So on number 1, we can do this, that they look exactly the same. So there's one line of symmetry, and then I can draw another one here. And then I could draw another one here. And another one here. So we have 1, 2, 3, 4. 4 lines of symmetry. Okay, let's try number 2. If I go like this side jets off to the far, and this is not so far. So it's not exactly. If I draw it here, it's not symmetrical because this would jet off all the way up here. If I do a line across this here, this does not completely line up. So number 2, there's no lines of symmetry. Okay? Number 3, I could draw a line right here. I can draw a line from each vertex. I can draw a line right here. So here there's 3 lines of symmetry. Number 4, I can just split it in half. It's the only line of symmetry that makes both halves look exactly alike. All right, so then the last, no, we're still on reflections. So what it looks like on the coordinate plane is something like this. Now imagine. Now notice when I'm doing here, look at C. Notice C is 1 unit to the left of this. I'm going to go 1 unit this way. Okay, that would be C prime. And notice from the origin, it's A is 1, 2, 3, 4, 5. 5 to the left, and 1, 2, 3, 4. So my new A is going to be from the origin 5 to the right, and then up 4. And that would be A prime. So this is how we kind of do our reflections. Here I've given you the other triangle. I wanted you to see what it looks like on the coordinate plane. All right, so triangle A prime, B prime, C prime is the image of triangle ABC. ABC being the original, A prime, B prime, C prime being the new one. Now, you can look at what's happening, what happened every time. So my X here, it was -5. Here it's +5. So what's happening, but let's look at our ordered pairs. So this is -5, -5, and then so I'm starting at the origin, 1, 2, 3, 4, 5, up 1, 2, 3, 4, comma 4, and then here it's +5, +4. Now what changes in that point? Does the X change? Does the Y change? Hopefully you figured out that the X has changed. So the rule is it's the opposite of X, comma Y. Now this is when we are reflecting over the Y axis. Okay? And then the Y is going to be the same. So that's basically the rule here. And you can see that each time the X is opposite and the Y's are always the same. All right. Now, reflection or rotation. Let's see. Let's now talk a little bit about rotation, our third kind of movement. Now, a rotation, all of these are called transformations. Transformations change where the object is in space. So a transformation that turns about a fixed point is called our center of rotation. The way we move, they move rotations in 90 degrees, 180 degrees, and 270 degrees. And I'm going to show you that. Okay? A quarter turn, a half turn, 3/4 turn, 360. Something called rotational symmetry is if you can rotate the picture 180 degrees or less and its image looks like the original figure. So let's look at all 3 of those. Angles of rotation, rotational symmetry, and what it looks like about a center of rotation. Take a minute, pause the recording, and write down the notes. All right, let's get going. Okay, rotation or reflection. So if I go from here to here, is that a rotation or reflection? Take a minute, write it down. All right. Hopefully you said it's a rotation. Now notice this did a quarter turn. That quarter turn is a 90 degree. So if I'm moving it to the right, it's considered a 90 degree rotation clockwise. If I move this high end all the way around his way, it's 270 counterclockwise. So it's 90 degrees clockwise and 270 degrees counterclockwise. Now, rotation or reflection. Let's see. Let's look at the transformation. it really could be either, because we can turn it, it's going to look exactly. Now, this is something we would call rotational symmetry. Now, rotation or reflection. Definitely rotation. Definitely rotation. Again, this is 90 degrees clockwise. 90 degrees going, since it's going in this direction, it's a quarter turn. That's 90 degrees. Or if I go the other way, notice I'm going, this would be 270, because I'm moving it down and across and then up. Okay. If the mirror were down at the bottom, I would say, and then we had it below, then I would say it's a reflection. But since it is opposite, I would say that it is a rotation of 180 degrees. Notice it moved exactly 1/2, so it turned completely over. That's what we call 180 degrees, right? Almost like a half circle. All right, 270 degrees, 180 degrees, or 90 degrees. Let's look. So if we're going clockwise, it would be 90 degrees. So that's 90. If I moved it down to the bottom, it would be 180. And if I moved it left, it would be 270. But if I go the other way, counterclockwise, it would be 270 degrees. All right, pause the now take a look at this and you write down your answer. Look at the transformation. What is it clockwise and what is it counterclockwise? All right, so hopefully clockwise, it's a 90-degree rotation, and counterclockwise, again, it's 90, 180, 270. This is always the tricky one. Sometimes I see it, sometimes I don't. I'm going to be honest. So, 1, 2, 3. I think it would be 180 if this is going all the way to the other side, the dark shaded part. Right? This is moving all the way to the bottom. This is moving, so it's going to have to be 180-degree rotation. All right. Notice this line here. Write down your answer. And I would say it is a 90-degree rotation. 90-degree rotation. Clockwise, 270 if we go counter. All right, rotational symmetry is when you can rotate a picture. That should read 180 degrees, not 280. And so I'm going to just, rotationals when we can rotate it 180 degrees or less, and its image matches the original figure. So let's look at, okay, let me go back. Okay, 180 degrees would be here, and it's going to still look the same. Looks the same, looks the same. So that has rotational symmetry. Let's look at the next one. 180 degrees or less, and it looks the same. And last but not least, everything except for that order 3. So rotational symmetry. And of course, our last picture, if I rotate it 90 degrees, it's still going to look. Believe it or not, this is, I think this is DNA. I thought, what a perfect picture of science to end this rotational symmetry. No matter which way we turn it, it's going to look the same. And that, my friends, is the end of our lesson. So please come stop by the Learning Lab if you need help with homework. I'm happy to help. Have a great day and see you when school starts.